I would imagine we'll get one or two more people. Thank you for starting the recording. So let's go ahead and jump in. It's a small group, but you've got some really good folks on the line to kind of introduce yourself to here, Sharif. And I'm excited to hear about your work, and we'll get this up on YouTube afterward and share it around. So with that, I met Sharif over the phone for the first time a week ago, and we had a good conversation about where we're going this year, kind of what our plan is, just tactically for the IT&I. But other than that, I have not gotten to hear about his work. Congrats on getting the community fellow position. I'm really glad to have you. And other than that, I'll let you introduce yourself and let you take it away. I am going to be taking notes in a Google Doc that I'll put in the chat once more. Would very much appreciate some help capturing some takeaways or just quick thoughts in minutes. These will end up on the wiki with the recording, and from there I will go on mute. Hopefully I can stay most of the way through. I may have to drop off to get on a plane, but if I'm gone, go ahead and just finish up without me, and we'll see you another time. So thank you much, Sharif. Go ahead.
Thank you so much, Jeff. Hello, everyone. My name is Sharif Islam, and I am a postdoctoral researcher at MIT in the Space Enabled Research Group at MIT Media Lab. And recently, I got the community fellowship with the SU. So I'm excited about that. And today, I would like to talk about some of the research that I did during my PhD, as well as currently I am doing here at MIT. So yeah, it's just kind of like overview of what of the research that I did and I'm doing right now. So with that, so you might have seen this video over and over time. This is a NASA video showing NASA has different Earth observation satellites. Those are capturing images of the world, and I believe like at least 4 or 5 sources of data that is being shown here, the different missions. I actually use their data set, for example, Landsat, Aura, Terra, and then there is SMAP data we are using currently at MIT as well. So I actually used some of the sources of data from their missions. So I would like to talk about some of the data set that we used from NASA. Also, I would like to talk about one of the projects where we actually use data from other sources, model data, as well as other things. So yeah, so since I mentioned like in the title that we are working on many different social and environmental issues mostly in the developing countries, even though we work in the US as well with some tribes, but mostly our work is focused on developing countries like in Asia and Africa, South America as well. And I believe like some of the things I'll be talking, those are contributing to at least, I don't know, maybe 5, 6 of the Sustainable Development Goals. And yeah, so before I jump into the things I will be talking about, so I would like to mention about this framework. It's called EVTT framework. So this framework is developed by my advisor at MIT, Daniel Wood. And this model, so when we look at any environmental or social issues, we look at that not only, we are not only using satellite data to model some kind of environmental issue. For example, like looking at, coastal erosion. So we are not only looking at how shorelines are moving, rather we are also looking at other issues as well, socioeconomic vulnerability, people's decision-making, and the technology availability to them. So combining these 4 words, EVDT actually stands for environmental. So combination of environmental model, socioeconomic vulnerability model, decision-making model, and technology model. So as I said, like I will be talking about some of the problems that I worked on during my PhD, like the first 2. So my dissertation research was actually related to coastal erosion in Bangladesh. So I'll be talking some part of that. As well as during my PhD, beside my dissertation, I also looked at air pollution in South Asia as well. So I'll be talking about that. And currently at MIT, I am looking at drought vulnerability in Angola. So we are using satellite data to model how drought is happening over time, agricultural drought. So I'll be talking about that. And then we'll be talking about some other research that our lab is actually doing in some other countries or previously did. So I'll covering some of the stuff like deforestation in Ghana, in Africa. Then I'll be talking about our research related to biodiversity in Lake Nokui in Benin in Africa. Also, I will be talking about our previous project in Rio de Janeiro, Brazil, where we looked at mangrove forest loss. So yeah, so I'll be talking about part of my dissertation research where I looked at coastal erosion hazard in Bangladesh and associated vulnerabilities there, how people are vulnerable to the changes. And you might know, like Bangladesh is one of the countries which is prone to natural disasters, like one of the biggest hotspot of natural disaster. And many different natural disasters are happening there. So flood is one of the big natural disasters. There's cyclones, storm surges, riverbank erosion is one of the things that I looked at. And recently, like not recently, actually over the last 30, 40 years, like so many people are being displaced because of coastal erosion and all these issues. And environmental migrations are happening. And our research found that coastal erosion is actually among the highest in the world, and it is one of the major natural disasters occurring over there regularly. And because of the location and other things, so I'll be talking about those in the later slides. But like as I said, like erosion is highest, one of the highest in the world, and it is actually causing different problems, including loss of households, productive lands, infrastructure, displacement of population, and most importantly, loss of livelihoods. So as I said, like one of the issue is the location of the country. So if you look at this entire figure here, so this red boundary is showing the delta region. It's one of the biggest delta in the world. It's called Ganges Brahmaputra Meghna Delta. So this is not actually the entire thing is actually the basin, but the delta is located here, and I'm looking at the mouth of this delta in this yellow boundary. So this is actually part of Bengal Delta, but the biggest mouth. I mean, they have multiple channels, but this one is the biggest. So my research looked at how coastal erosions are happening, how people are being displaced, who are being displaced, and like what will happen in the future as well. So as I said, like you see, like all this, so there are hundreds of rivers here. So this area is covering mostly India. Then there is Nepal, here is Bhutan, this part is China, some part in Myanmar as well. So there are many rivers here, and all these rivers are flowing water to the downstream to the Bay of Bengal in this area. And when the water is going to downstream to the Bay of Bengal, it's actually eroding the river banks. And because of that, so many people are being displaced. So one of the main issues is actually the location of the country. So here I show so we used Landsat data to actually look at how shoreline is moving from 1988 to 2018. And as I mentioned already, we found that the erosion rates are among the highest. So I'll be talking about some of so if you look at the first figure here, so the red areas, dark red areas are showing the red areas are showing the erosion, and the green areas here are showing the accretion. But if you look at the dark red area, if you look at this one here, so the dark red area is showing the erosion rates are more than 300 meters. So this is important information in terms of when we talk about coastal erosion in the US or other parts of the world, like we mostly talk about 1 meter, 2 meters of erosion every year. But I'm talking about in some areas, the erosion rates are more than 300 meters. And because of that, the main problem is, you might know, like Bangladesh is one of the, mostly one of the densely populated countries in the world. So people are living everywhere. And then the question is, who are living near the riverbank? So those are actually the marginalized people who are actually depending on on fisheries and agriculture for their livelihood. So these, marginalized people are being displaced and they have nowhere to go. they don't have money and resources to actually go to other safe places. So that is another issue here. So as I said, like, it's not only actually causing, so coastal erosion is not only causing the erosion of, people's house and agricultural land, it's also, creating new lands as well. So over time, so the central area is actually showing how, new areas are gaining because of the deposition of the sand over time. So now I would like to talk about some of the, so one of the aspect of my dissertation was looking at combining, both remote sensing and social survey data, where I looked at how, people's prediction of coastal erosion risk is aligned with the actual coastal erosion. So in that case, as I mentioned, like I combined both satellite data from Landsat from 2008 to 2023, every years of data. And then I also used the social survey data. So this project was funded by NSF, and we had 420 survey that we conducted back in 2018 when I started my PhD. It was actually before my starting my PhD. So we actually collected information related to, the respondents' demographics as well as their socioeconomic status and their risk perception about this coastal erosion. So as I said, the survey was actually collected back in 2018, and in 2022, when we actually, checked with the shoreline data, we found that among these 420 people, 141 people already have lost their houses into the water. So they have gone somewhere else. We don't know where, maybe nearby areas, maybe some other countries, not some other countries, some other cities, maybe in the capital or other cities. And this is interesting, like, like almost 1/3 of the people are gone from these areas. And this figure here is showing, so if you look at the red dots, so those are showing the people's location, their household, those are in the water already within this 4-5 years, 1/3 of the people in this area. And we conducted this survey within only, 12 kilometers or so. But the shorelines or river bank is like very, long, maybe few hundred kilometers or so. So this shows like how devastating is the situation in terms of how shoreline is moving and how, people are being displaced over there. So one of the main thing was for this, for this part of the research was we fit a logistic regression model to see like if people's prediction was accurate or not. And we wanted to see like what drives their accurate prediction. And we found that some of the variables like, completed level of education or distance between house and shoreline, those were actually statistically significant. So as I said, like, like we initially tried like, so we initially had, I don't know, maybe 30 variables or so. And we came to the final model actually included these 5 variables where we found these variables are actually statistically significant. And the key findings of this research was like we found that from existing literature, when we compared the erosion rates with, existing publications, that what are the, erosion rates in other parts of the world, and we found that the erosion rates are highest, one of the highest in this region. It was actually highest. And then we found that from the people's perception, they think that concrete embankment is the solution in terms of saving their household and agricultural land. And then the problem of, economic situation, because Bangladesh is not rich, and because of that, they cannot actually invest billions of dollars, saving this land. So maybe in the future, maybe that is possible as well, but that will be like big investment is needed actually for saving the entire country from erosion and other things. And then, as I mentioned already, like some of the variables like elevation level, proximity to coast, or residents with electricity were found to be statistically significant in terms of what predicting, the coastal erosion risk accurately. Now I would like to talk about the particulate matter pollution research that I did actually during my PhD. So this was not my dissertation, but I looked at that issue because of my interest about like how people are impacted in that region. So I looked at how, particulate matter pollution is happening over there, as well as looked at how, this long range air mass actually being transported over there, as well as the mortality. But I'll not be talking about the entire paper. I'll just show some part. And so here's some background information about this issue. So as I said, like not only Bangladesh, like all the countries in South Asia are like very densely populated, and about 22% of the world's population are actually living in this area. And that is only 3% of the global landmass, but the people are like 22% of the world living in these countries like India, Bangladesh, Pakistan, and others. And according to WHO, World Health Organization, in 2016, they found that like 10 out of 20, world's most polluted cities in terms of particulate matter 2.5 are in South Asia. So like right now, maybe even more, maybe I don't know, maybe 13, 14, or 15, topmost, polluted cities in the world are located in South Asia. And one of the issue of in terms of why the this region is was most polluted cities are located at. The main reason is like because of the urbanization and economic development, industrialization is happening. Because if you look at the GDP growth rate, those region has one of the highest rates of growth in the world. So that is one of the reason, and there is no actually adequate technologies or structure for regulating the pollutions from different industry and other things. So that is another issue. So here I show like the spatio-temporal variations in PM 2.5. So it shows like how PM 2.5 in South Asian region is actually changing from 1980 to 2019. And it shows if you look at the recent year maps. So this data was actually, this is not actually directly satellite data, but it's a model data developed using satellite data by Socio-Environmental Data Application Center at Columbia University, NASA CDAP. So they actually have this data, and we actually use that data to see how these things are over time changing. And we actually looked at how the trend is, like if the at country level, if the trends are increasing or decreasing. And we found that like except Maldives, like all these other countries are actually having increased, increasing trend of particulate matter that in that region. And the highest, increasing trend was found to be for Bangladesh, and then Nepal, and then Bhutan and India as well. So India and Nepal has the same mental. So yeah, so it's increasing in general, except Maldives over there. And we also wanted to see, like, like air pollution is not only about the local pollution, it's about like pollutions from other areas as well. So we wanted to see how these pollutants, if coming from other side, where from they are coming. So we used this high split model developed by, I think, NOAA. We used that to actually see where from the air pollutants are coming in the big cities in South Asian countries. So these are the cities where we looked at like how these cities are being air pollution are actually coming, air pollutants are coming from outside as well. So these lines are showing different clusters of where from the air pollutants are coming. So we actually use so for this one. So as I mentioned here, for every 70 hour for every day actually we calculated the trajectories, and there were hundreds of trajectories for each series. So if we use like all the trajectories here, it will be like super crowded. So we actually used a clustering tool called transistor to actually show like only measure clusters where from actually the air pollutants are coming. And with that, so I would like to now talk about my current work at MIT. So here I am actually contributing to two different projects. So one project is related to drought in Angola. So we are using satellite data to actually look at this issue there, as well as I'm also contributing to another project. So we are estimating methane gas emissions from landfills in Brazil, but I'll not be talking about that, but some of the research in Brazil as well. So we are actually using a satellite data called SMAP, so soil moisture active passive. So we are actually looking at how root zone soil moisture is actually changing over time. Because of that, how agricultural drought is happening there. So we are using the same same index developed by US Drought Monitor. So it's called D0 to D4. So D4 means this dark red areas are showing exceptional drought, And then the white area showing there is no drought, or D0 is showing abnormally dry areas, but not like in very extreme. So we use the similar index for the country of Angola. And this map is showing like, I think southeastern part of the country, where you say like the same index, like the red dots are showing the exceptional drought happening there. And now I'd like to show one of the videos we have. So it's showing like how, so we have data every 8 days. So we actually wanted to look at how these, soil moisture things are changing over time. So this shows like how these things are every 8 days changing. So this, as I said, like the red dot areas are showing extreme dry soil, and then the white areas are not like relative drought, like below average kind of thing. So this shows like how these things are changing over time. Yes, and we wanted to see like how, spatially and temporally it's actually changing. So this one is showing only for a province called Canene, and this shows like how this soil moisture, percentage of soil moisture based on different levels like D0 to D4 are changing. So the dark red areas are showing the abnormally very strong, what is called, that category is called exceptional drought. So this is actually showing the exceptional droughts are happening in some seasons and some of the months of the year. Some years it was very extreme, and some years it was normal or kind of thing. So we also wanted to look at that issues. And as I mentioned at the beginning, we are also looking at other things as well, like socioeconomic vulnerability and decision making thing as well, like how decision making processes are happening there, who are taking the decisions, if people have bias in terms of those decisions, what technology they will have and other things. So we looked at the socioeconomic vulnerability model as well. So we are combining a proposed method that IPCC, Intergovernmental Panel on Climate Change, actually proposed of looking at vulnerability. So they mentioned that when you look at vulnerability, we need to actually add this information's exposure, sensitivity, and adaptive capacity. So we are actually following their way of looking at vulnerability. So we are combining different sources of data to actually look at the socioeconomic vulnerability model, like how people are disproportionately impacted by drought. So this is ongoing work, so I don't have the final result, but I just wanted to show like we are actually doing this, in that country, in Angola, using satellite data and other sources of data, looking at drought issue. Now I would like to talk about some other projects that our group actually did or currently doing actually. So this one is ongoing work in Ghana, where we actually looked at the deforestation issues that is happening because of mining in the southwestern Ghana. And here are some of the collaborators. So we are collaborating with the government organization in Ghana, as well as NASA is one of the collaborators as well. And as I mentioned, like we are looking at only not the entire country, but southwestern Ghana. So this is the area we are looking at. And this figure on the right is showing how mining are actually increasing over time. So from 2008 to 2017, in most of the years, like until 2016, it actually increased over time. And the urban areas and other areas are decreasing. So we use Landsat data for that. And one of the main background information that you need to know is like why it is important, like in terms of mining, why mining is happening. So Ghana is the 7th largest producer of gold worldwide. So that is one of the main issues why mining is happening. And mining is not only happening by only the big companies, but the artisanal mining, small scale mining, like maybe few people are doing like this kind of mining thing. So artisanal minings are increasing over time, like small group of people are actually doing the mining thing, not big companies. And because of that, it's actually deforestation is happening. And this shows these orange areas are showing actually the big companies who are doing actually mining there, but these yellow areas are showing the artisanal mining. So those are a small group of people who are doing mining, maybe local way of mining gold. With that, I would like to talk about a little about our work in Benin as well. So where we are looking at how water has in this actually impacting the biodiversity of it. One of the, I think the largest lake in Benin is called Lake Nopui. So it's a, I think, French word. And yeah, so we are working with Blue Raster to actually develop a decision support tool for them so that they can monitor different how water hyacinth is actually changing over time, as well as, so we are using Google Earth Engine to actually do that. So we mostly use actually for all the projects. We actually use open source tools like Google Earth Engine and others to actually have them like those code available so that they can actually monitor what like in the future as well. So we are collaborating with some government organization there. For example, in this case for Benin, we are working with their water institute, like Institute of Water Benin or something, the name. So we are actually estimating like what areas of this lake is actually impacted by water hyacinth. So this is showing like, so one of the main issue here, why it is important to actually assess that is because like this lake is the biggest lake there, and so many people are dependent in this lake for their livelihood. So they catch fish and then sell it in the market, and their livelihood is dependent on that. And then the other thing is the transportation. So they use small boats actually to navigate from one area to other. So that is another thing. So if there is water hyacinth, so they cannot easily navigate from one area to other. And it's a poor country, so they don't have the other road infrastructure like very well around the lake. So that is another issue. And this one, like navigating by the water using a boat, may be the easiest one. So this is important for them. And this is showing the dead water hyacinth in some part of the year. It actually like water hyacinth actually those are getting dead, and because of that the odor is the problem, smell, and fisheries is impacted by the dead water hyacinth as well. And so we actually, so I was not here during that time, but our team actually went there to actually set up some of the things, how we can actually monitor the lake water quality as well, like temperature, BOD, COD, those kind of thing. So we actually had some setup with the people at Institute of Water in Benin to actually monitor the water quality there. And finally, we developed a decision support tool for them. So it's a web-based app, web-based tool, so that they can actually monitor like how water has happened over the years, as well as looking at different socioeconomic and other information as well. So they are actually using that right now. And then finally, I'll be talking a little about like we worked in Brazil as well. So we looked at how, in Rio de Janeiro, how mangrove loss happened over the years, as well as like how different socioeconomic aspect and other things are being impacted by the loss. So we combined, as I said, like at the beginning, like we are using EBDT framework. So we use the same framework to actually look at this issue there and combined information from different sources like geographic informations. In terms of environmental model, we looked at temperature, salinity, weather, and mangrove data from cell Landsat and other things, and also looked at like how they can actually use a decision support tool. So we developed a decision support tool for them in Portuguese so that they can actually use to monitor mangrove loss there. And the final decision support tool, this is the screenshot of that, and right now they are actually using to monitor that. And yeah, with that, so I would like to conclude my presentation, and thank you so much for your attention, and I would love to take any questions you might have. Thank you so much.
Excellent. Thank you, Sharif. I guess I would open the floor to anybody that wants to pose questions. There's a lot of different topics there that people might be curious about. If nobody has anything right off, I wonder if you could spend just a few minutes talking about the kind of the general framework that you guys are using is this EVDT, environmental vulnerability decision technology. Especially, how do you, I guess, how do you frame using social survey type data in that context?
Yeah. So let me go back to that slide. So I actually didn't present all the components of EVDT framework in my slides because of the time, since I just wanted to show the overview of the research that we're doing. But yeah. So as I
So I
mentioned,
just
like,
the reason I guess I'll just frame that a little more. The reason I ask is I recently did um, I did a totally unrelated to anything like what you're talking about study where we collected data, we collected observational information about what people are doing in the real world, and then we surveyed a whole bunch of people to get their perspectives on exactly the same thing we collected data about, and it was combining the two is a very I don't know. I'm curious about the structured ways that people combine like observational data and surveyed or human impressions.
yeah, so that's a great question. So one of the thing we actually do, so one of the main goal of this project in Angola, so we are using this one in Angola as well. So I can give example of my drought work right now going on, and I'm going to Angola next week as well. So I'm excited. So the thing is, like, we are combining all these data sources, and so the environment model data, so those are coming from different sources. For example, we are looking at this map, as I mentioned, to look at soil moisture, as well as we are combining other data set like precipitation, and other things as well, not sea surface temperature. So this is not specifically for drought, but it's combination of other things as well. But we are not like combining all these things together in a paper. Rather, we are the main goal. So this project is funded by NASA Applied Sciences. I think NASA Water Resources Applied Science Program or something. NASA Water Resources. So one of the main goal is to actually train the people in the decision making, who are involved in decision making process in Angola. So we are actually working with a team from, it's not actually a team, the director and associate director and others in a organization called GGPEN. So this GGPEN is like NASA of Angola. So they are the space organization, they are government organization. So we are working with them so that like they can actually in the future maintain a decision support tool that we are developing. So in the decision support tool, we are combining all this information. So we are using satellite data to actually look at how over time this soil moisture is changing. So that information will be there. And then we are also adding socioeconomic vulnerability index data at municipal level, so that they can look at like at that municipal. So they have, I don't know, maybe 170 municipal boundaries or something. So at each municipal, they can actually look at how that municipal is vulnerable to socioeconomic status and other things. And based on that, they can also look at in that municipal how the soil moisture are happening over there, as well as so this decision making thing is we are talking with two levels of people. So one level of people is the government people, as I mentioned, like GGPEN. So we are talking with them like what kind of things they are using to monitor soil moisture or agricultural drought, and or what kind of tools or apps people are using to monitor this kind of thing, how people take actually decisions of drought, how if there is any or not. So that is one thing. Like we have a research scientist who her background is actually related to this thing. I don't understand that much about decision making and technology part, but we have other people who are also contributing those social survey aspect as well, bringing them in the decision support tool so that people can actually see those kind of information as well. I'm not sure like if I answered your question properly, but that was like in general, like we are combining all these informations in a decision support tool. So that is the main aspect. And when we are writing papers, so this index or different components, we are actually not like in a paper we are actually combining all these materials together. But in the decision support tools, all this information will be available, but the individual, scientific aspect we are publishing, so those are individual. So when we are looking at SMAP data, so we are just trying to write a paper based on that, not combining other things like socioeconomic or decision making or technology aspect in that way.
Well, that makes sense. I think that's helpful to get a little more nuance on what this model is about. So thanks for that. Any other questions or points you'd like Sharif to expand on?
Sharif, I have a question. I don't know if it's kind of a recapitulation of what Dave just asked, but I guess in all of this work, you've been talking about risk and perceived risk a lot. What have you personally learned about communicating risk to citizens, or it sounds like you're talking about local level decision makers throughout, the many places you've been?
Yeah, so I can talk about the coastal erosion thing in Bangladesh. So we had collaborators, so we had stakeholders from government level as well. So it's a British system. So we call MP, just like in the US, congressman or senator kind of thing. So in this project, one of the MP was actually involved. So even when my advisor and other collaborators went to Bangladesh, so they've been to his house and all the steps. So one thing we did was like when our project was done, so we had developed some leaflets to actually share with the people as well as policymakers as well. So there are like upper tier policymakers like MPs, and then there is like local administrative level people. So when we like been there after when the project was at the final year, so we've been there and as I said, like we shared leaflets with the general people, and some people were surprised to see like these things are happening over the years, and the way they perceive is different, but the way like when like we had this kind of question as well, like what do you think, like how much shoreline has moved? So their perception was like say 2 kilometer, 3 kilometer, 4 kilometer. When they saw that the entire thing actually the magnitude was this high, they were surprised in some way, some people. So our goal was to actually share that with policymakers as well as the local level people, like the mass people. And in the case of drought, I can talk about like as I said, like the main goal is to actually develop this tool and then giving it to them so that people can actually look at that. So that will be the main outcome of this project, so that like people will be using this decision support to look at actually how people are being impacted by drought, or what is their socioeconomic status and other things as well. So that would be the main goal. But again, like we are working with not only the policymakers, but also how to say like grassroots level NGOs and people as well.
Thanks so much, Sharif. There's a lot of complexity there. I appreciate the thought and the nuances to, working with people and deciding when is a technological solution the way to go, and when is the challenge a little bit different. Any other questions? I'm taking over for Dave here, who had to board an airplane. Any other questions for Sharif today? You're welcome to pop them in the chat or just come off mute or a small group. And that's okay if not, because Sharif will be with this committee for the rest of the year. So you have 11 more months officially with him to ask questions about his work. And, I'm sure he'll jump in and get involved in other IT&I activities. But I want to say thank you to Sharif again, especially for jumping in his first month here, without even having seen an IT&I webinar, to jump in and present himself. And thank everyone else for coming along. And we look forward to reconvening soon. We'll see some of you at the ESIP meeting in a couple of weeks as well. And that's about it.
Thank you, Megan. Thank you, everyone, for joining.